Hey, good morning, everybody. We are live. Hey, it is a special day again today. We have an awesome guest by the name of Dr. Antoine Bret. He's a French plasma physicist with academic credentials of the yin yang, and I'm not going to be able to read them all out, but they are listed in the description. But he has been a former professor at Harvard. I believe he works in Madrid now, if I'm not mistaken. But he's here to talk a little bit about plasma physics, and especially lately we had C. Brown claim something right up his alley, that Z-pinch was what created all the elements like 7,000 years ago. And so I am going to ask him questions directly relating to this claim, because as a PhD in plasma physics, he's just kind of right up his alley. So anyways, I'm going to start it right off. Hey, welcome, Dr. Bret. I'm happy for you to be here today, man.
Hello, thank you.
It is, by the way, in his time, it's like 6 o'clock or 5 o'clock in the afternoon.
Yeah, it's 5 p.m. here.
Yeah, so everybody else is like waking up over here. So anyways, I sent you what C. Brown had said. What was your reaction? And I will find exactly what I wrote to you as you're giving your answer here, because it's pretty bad.
Well, I find it really weird because if you want to start from hydrogen and build up a nuclei, you need to have your two hydrogen to fuse, and the protons in the hydrogen, they don't want to see each other until they are really close to each other. And so if you really want this to happen, you need millions of degrees. That's why controlled nuclear fusion is so difficult to achieve, because you need to control a gas at, let's say, 100 million degrees. Okay. So the center of the sun is only 1 million degrees, but you can wait a long time. You have all the time you want. And so if the sun was hotter, by the way, it would burn much faster. So just without even talking about iron or uranium or whatever, just to create, to generate helium from two protons, you need a few millions degrees. So this has been achieved in inertial fusion, in magnetic fusion, in Z-pinch. The most powerful Z-pinch on Earth is in Albuquerque, in a Sandia National Lab. They've reached even billion degrees over there. So you definitely see helium going out of it, but you see nothing else. And so the experiment has been done. So first, even in a million degree Z-pinch, you don't get to, you don't even get to carbon, for example. And then, Steve, you told me that apparently they were counting on lightning as natural Z-pinch, isn't it? And the temperature on the lightning is a few tens of thousand Kelvin. Let's say 20,000 Kelvin to be generous. So at 20,000 Kelvins, you don't have any nuclear reaction. You don't fuse anything. So, and the third reason why I was really surprised about that claim is that I don't see how the literal reading of Genesis, which I don't share, of course, but I don't see how the literal Genesis requires this. If I were a younger creationist, I would just say God created the sun, and so God created all the elements which are in the sun. And if you look at the spectrum of the sun, you see iron inside. There is iron in the sun. So apparently they invented a scenario, a creationist scenario, when they need it, but counting on natural lightning to generate uranium is like saying the Earth is flat. It's completely, from the nuclear physics standpoint, it's not going to work at all.
Yeah, let me read what actually he wrote, because I think it's good we get this on record.
Yeah.
He wrote, and I'm going to read the whole thing, because this is actually the blurb that I had saved. This was talking about sun absorbing heat and stuff, and black body radiation. But he said, the sun can absorb heat. What are you talking about? Look, dumbass. It was proven in the Proton 21 lab, you stupid ass. They proved super heavy elements with short half-lives of 10 minutes to hours. Those unstable elements decayed down to the 94 elements. They didn't melt the Earth's crust. They created a Z-pinch machine because of the power of Z-pinch. Now, I know there's so many things wrong with this. I couldn't even begin to parse it out. I don't know what he means by 94 elements. There's actually 118.
Yeah,
natural ones are anything below uranium and below, and that stops at 92. So I don't know where he gets to 94. That'd be plutonium. But I mean, how could Z-prints even create something higher than like the transuranic elements and then have them decay down? How would that even be conceptually possible?
Well, it's even really difficult to imagine it creates something beyond helium. Or you would need a huge amount of time. So that's what happens in stars. You have millions of years and a lot of gas together. But Z-pinch in the lab lasts 1 nanosecond.
Wow. And what's the highest element they've ever created with Z-prints that you're aware of?
Well, I never heard of anything heavier than helium.
Okay.
So I did some homework before today because you told me about this. So I never heard anything, beyond helium. I tell you, because to go beyond helium, you need even higher temperature. You need a lot of time. For example, well, I don't know if you want to talk about this, but in the Big Bang nucleosynthesis, this period of universe where the universe was hot enough so that you have nucleosynthesis, the universe didn't go beyond the lithium of beryllium, something like this. Didn't even get to carbon.
So you mean like during the on Planck scales or the early?
After.
Oh, after. So even if the earlier it didn't. So all the heavier nucleus came from basically nova, stellar eruption, explosions of some kind, whether it be a supernova or a compact binary collision. They came from very violent things, correct?
Yeah. So among the violent things, you have what happens in the stars. You have what happens when the stars explode, supernova. You have also, what you can do, guys, is you look at periodic table and then nucleosynthesis. You Google something like this. And you have periodic tables which are colored according to the way these elements were synthesized. And so you see a Big Bang nucleosynthesis, you see supernova, you see stars, and you see also cosmic rays, because that's also a violent event. If a cosmic ray, a super high energy proton, for example, coming from space, hit a nuclei, it can go inside and then create a slightly heavier nuclei. But even in this window, in the Big Bang story, at first it's so hot that you don't even have protons. You just have quarks and gluons dancing around. Then it cools down and you can have protons and neutrons. And it's hot enough so that you can have helium by fusion. And then it still cools down, and then it becomes too cool just to be able to have nuclear fusion. And so you have a time window, I think from maybe 3 minutes to 20 minutes, something like this, when you have nucleosynthesis, mainly of helium, lithium something, deuterium also. And you see, even in this time window, the universe couldn't get to carbon. For carbon, you need a lot of time in stars. So doing this in a few nanoseconds or in a few microseconds in a Z-pitch, it's completely unrealistic. So once again, I don't know if this person found some report somewhere. I would super doubt that there is a peer-reviewed publication telling this.
I don't think he actually knows how to peer-reviewed publication, actually. I just don't. You know, there's another claim that he actually put out, and I don't know if a lot of people in our community remember it, but he actually at the same time had said that we have never discovered heavier lines in spectral emissions from stars, whether it be absorption or emission lines, that we have never detected heavier elements in stars.
Well, no.
you can say bullshit on my channel. It's okay.
So first, I don't know what it calls heavier, but for example, I just looked up recently. There is iron in the sun. So I don't remember the percentage. It's not a lot, of course, but people who do spectroscopy, they see iron lines in the sun. So something that may be really exotic, but maybe we're going to love it. One of the two top methods astrophysicists have now to deduce the spin of a black hole, how fast it turns around, is based on an iron line. So you have iron lines, namely irons, all over the place in the universe. So I don't really know what he means by we never found heavier elements.
Let me present this while you're saying that, so people can kind of see what we're talking about here. The sun spectral lines. You want to kind of explain to people what can you see these? This is obviously the spectrum, and explain to people what these lines actually represent and why they're darker.
So when you put hydrogen, for example, or helium or whatever elements in a tube and you just heat it, and you look at the light it emits, you are not going to find you are going to find discrete wavelengths. It's not a continuum, and that was, by the way, the beginning of quantum mechanics, almost more than 100 years ago. Then people realized with hydrogen that you just have this wavelength and this wavelength and this wavelength and this wavelength and nothing in between. And so people were wondering, how is it that you don't have a continuum of emission? And so if you know the position of all the wavelengths, it's like the barcode of an atom. Molecules also emit a discrete wavelength, so that you have a barcode of molecules, and you have also a barcode of nuclei, because if you excite the nuclei itself, it also emit light, in the gamma band, really energetic light, but on discrete wavelengths. And so when you look at the light of the sun, for example, all of these barcodes are superimposed. Because you see hydrogen, iron, sodium emitting all at once. But if you are trained to that, you can disentangle the barcodes. You can say, oh, this line are the superimposed barcodes or sodium and oxygen, for example. And if you look to someone who's been doing this for 20 years, looking at that spectra, it will tell you right away, this is oxygen, this is iron, this is calcium. Even with one line of the barcode. And then usually, for example, here, you have 2 lines of oxygen, you have 5 lines of iron. So this is a way to unambiguously know that up there is iron, there is sodium, there is oxygen, and all that.
So this is actually a fingerprint not only of the elements, it's a fingerprint of the sun itself.
Oh, yeah.
So when they ask, well, how do we know what the sun is comprised of? Well, this is how we do it. We analyze the light and say, okay, these missing wavelengths are being absorbed by atoms in the sun. And we can say, okay, well, look, here's the ones for hydrogen. If we see those lines there, we know that there's hydrogen, that the sun is comprised of hydrogen, correct?
Yeah, exactly. As you say, usually what you are going to get when you look at the sun, for example, you are not going to see an emission line, you are going to see an absorption line, which means that this element, if it can emit these wavelengths, it means that it can also absorb these wavelengths. And so that's why you are going to have bars in the spectra. But by the way, this is how helium was discovered, if I'm not mistaken.
Spectral lines?
Yeah, it was spectral lines. People looked at it and say, oh, this is the line of hydrogen, and what are these lines? And I think helium was first discovered looking at the sun, and then found on Earth. But yeah, it's exactly a testimony of the composition.
I think his name was Fraunhofer lines.
Oh, maybe.
Yeah. I remember actually years ago having to do this experiment where we would take like a gas-filled tube, energize it, right? Put a voltage to it, high voltage. It would glow, put it through a prism type thing, and we would have to actually kind of guess what the thing was, right? Based upon what was in there and these lines. Way back when in some lab, but I don't remember where this lab was at.
Yeah, I just checked on Google. Indeed, yeah, it was. And there is a page, Universe Today. I don't know if it's serious, but it seems to. They say that, and I don't have any problem to understand it, that helium was found in the sun at the end of the 19th century. And at first, people thought it was only there. And then they found it out here on Earth. So yeah, that's how you can analyze the chemical composition of everything.
So when C. Brown says that we have not discovered heavier elements, and I would take him to mean anything beyond helium. I mean, I don't think oxygen is that heavy, but we've discovered iron 50 or oxygen, nitrogen, neon, anything like that. We have seen those spectral lines in stars, so we do know what's comprised of, contrary to his assertion that we've never seen any of those elements in the spectrograms, right?
Oh yeah, it's completely wrong.
Hey, C. Brown's completely wrong. Big surprise. Yeah.
So, maybe, I don't know, maybe he has the same understanding of heavy element that an astrophysicist. For an astrophysicist, heavy element is everything heavier than helium. For them, it's metallic.
Well, it's funny you mentioned earlier. You said something along the lines of why do they have to come up with these weird things?
Yeah, I don't understand.
I like your opinion on that. Why do you think they do? I mean, you're a Christian. You're a physicist. You believe in Christ, died for your sins, but you accept reality that the age of the Earth is not 7,000 years old. You accept reality that Z-pinch is not going to create all these elements as they're purporting. So why do you think they do it? I mean, why can't they accept the natural things, and they look at it and say, okay, I see the world the way it is, but I believe God did it. Nobody here in this room cares if somebody does it that. I particularly don't. So why do you think that it matters to them to try to just make science so abysmal to justify their religious beliefs?
Well, I suspect that when you've been raised like this, when you've been taught this from a Sunday school at an early age, and when you live in that bubble, getting out of the bubble is super difficult. I once heard someone, an ex-younger creationist, telling that while he was younger creationist, and he was starting to doubt, he was really aware that giving up on younger creationists means giving up of your community.
True.
It's not just an intellectual decision. And I strongly suspect that that's a big hurdle because deciding that because suddenly you won't be able to attend the same church. Usually church is, if you live in that bubble, and even for me, evangelical out of that bubble, for me, church is not just a place I go Sunday morning and then I leave. It's part of my village, I would say. It's part of my community. I have a lot of friends there and so on. So I can imagine it's a big hurdle. And also, if you've been trained from your youth to think that science is just a lie of Satan, and that they want you to lose your faith and all that, you are also the feeling that you persecuted, and you're fighting for your faith, and you are resisting. That these are feelings that as Christians we like. I'm going to do a bad joke, but we love to be persecuted.
Yeah, I think you hit the nail so squarely on the head. I can't even tell you how great of an answer that was.
It's kind of bad joke, but you feel like you're doing great spiritually if the world doesn't like you. And so I always feel that it's a really bad reason for which the world does not like you, because the world can hate you for good reasons and bad reasons, and that's a bad reason.
We call it persecution porn. Persecution porn is there's some people in the community that literally have to feel like everybody's coming down on them. It doesn't matter whether they're an atheist, agnostic, or another theist. They just feel like they're being persecuted against because we debunk their science. And that's a shame, because the science is independent of belief. Science is going to be what it is. Facts are mind independent. They exist because they exist. Whatever I believe to be a fact is not going to change the fact facts exist, right? Kind of a tautology, I guess. I know right now Alex Malpass is sitting going, shut up, Steve, don't talk philosophy.
We have a question from the med student. I'm going to try to butcher French real quick. Bonjour, Monsieur Bret. Vous êtes dehors?
It means where are you from or something like this, I guess.
Yeah, I'm going to assume.
I'm from Paris, France, but now I live in Spain.
Oh, cool. I'm from Louisiana, so we speak pidgin French.
Spanish, French, and English. That's amazing.
Hey,
and also I think that the third reason why it's difficult for these guys to get out is that, from what I see, the level of science literacy, I would say, is really low in these circles. I was recently looking at a poll that was done in the US, and Southern Baptist Convention has the lowest percentage of people having attended college. Almost all across the religious spectrum in the US. And so recently, for example, in Spain, I talked to a geologist who told me, when I was young in my church, I was a young God creationist. I went to the university. I even can claim I asked my professor, were you there? You know, the famous, were you there? But then I learned geology, and I learned that the reasons why these guys tell the world is not 6,000 years old, these reasons are not stupid. They've been checked over and over and over. And so he told me, I never felt like I was looking in my face. But here in Spain, I don't know in the US, but from what I see in the younger creationist circle, you don't have a lot of people, a lot of, I would say, people with college level in science. So it's really easy when you don't know the evidences or whatever. It's really easy to get to feel like, oh, these scientists, they just do this to crush the Bible, but they don't know. Well, it's really easy to feel like the rest of the world is ignorant where you are ignorant, basically.
I'm so glad you brought that up, because I've always said that I've seen people that were younger creationists do very poorly in college because they really have a hard time getting the concepts down. And I think that younger creationism is harmful to our education. I think intelligent design is harmful to our education as well. You seem to experience that firsthand, but you seem to be the kind of person that pulled yourself out of that younger creationist mindset and realize, that you can still be spiritual, you can still have faith, you can still believe in God, and not have to have bad science, right?
As for me, I became a Christian at 25 while studying my PhD in physics. And I was in a church with hadn't problem with creationism. We had other problems, but not that one. And so, as I told you, I was, during my first, I would say, years as a Christian, I was screened from this. And I rediscovered, I would say, 10 years ago. So I never had to get out of it. I just found out that, that's what you find in the evangelical world. And I wasn't even aware of it during, I would say, the 10 first years of my Christian life. Now since then, I've met a lot of people who were born, raised like this in Sunday school and so on. I never attended Sunday school, the concept of Sunday school, you don't have this in French. And I was raised, I would say, Catholic, but I wasn't believing in anything.
What would you say would be one of the challenges when discussing how other Christians reconcile their faith with what we know in science?
Well, I found out that offering a theological alternative is super important for them. Because if you cannot convince them that having a non-literal reading of Genesis 1 is not being a heretic, you will have a really hard time having them swallow anything else. So I know that from outside it sounds stupid, because it really sounds like all these guys I put in their book on the top of observation, and in a sense it's true. But I think you need to take people as they are. And so at first I just tried from the science angle, and you have this and you have this. So these are, for example, the last chapters of my book. But finally, if you look at the first chapters of my book, they are about the Bible. So they are about the reasons why I don't feel like an heretic. I never felt such by having a non-literal reading of Genesis.
If you can give me a link, I'll be happy to put in the video description. By the way, I did put in the video description my sponsorship, but I got a sponsorship now, and believe it or not, it's actually an atheist community. It's actually Atheist United and Celeb Atheist, I think they're called. Brian Sapien from the Rational Response Squad came on yesterday. He actually going to become a little bit of a sponsor to my channel, so I've said that I would include his links to future videos for a while in the video description. But also, in addition, I'm putting any links that you will have obviously in there as well for like your book. My channel is not about atheism or theism. It is about the science, and I think good rational conversation, and that kind of stuff. So please give me that information.
How do I post a link? How do I post a link?
You can just give me on Facebook, and I could do it that way.
Okay.
The name of your book is called "The World Is Not 6,000 Years Old." So what?
Yeah.
It's like, yeah, you know what? It's not that.
He wrote that book.
That's his book. Yeah.
I referred that to a friend.
Sorry?
I referred your book to a friend.
Oh yeah. Oh, I'm getting super famous.
Awesome. We'll make a famous person out of you yet. Actually, Wayne actually was kind of in a similar boat. He was a young Earth creationist. He's now an old Earth creationist. He teaches science now. So he kind of realized that, you know what, the young Earth creationist model just is not tentative. It's not supportive. You can't really make an argument for it.
And trying to become an astrophysicist in the next 9 years or so.
You're still going down the astrophysics route?
Oh yeah. So when I get home from college, General actually tutors me in applied mathematics.
Yeah, Wayne wants to be an astrophysicist.
Oh, okay.
I'm finding that a lot of actual I don't know what to say, old Earth creationists or theistic evolutionists, but people that are not young Earth creationists seem to be really fascinated by cosmology. Do you see that as well?
You mean from creationists?
Yeah, I see a lot of creationists that are really fascinated by the heavens and cosmology.
Yeah, I always have the feeling that everyone is fascinated by cosmology. The atheist, the creationist, the theist. Everyone.
That's what I wanted to be when I grew up. I'm not kidding. I wanted to be an astrophysicist when I was growing up. Then I realized how difficult the math was, and I said no, not going to happen.
But about that brings me an anecdote that's interesting sharing. According to creationists, the labs of the entire world are full of horrible atheists who want to destroy the Bible. And it's funny because, as you say, I spent, in the last 5 years, in total, I spent 1 year at Harvard Department of Astrophysics. And I had a lot of conversation about God over there. I know several of my friends there. are believers. And I even remember once I would go, I would just get to the office in the morning. And you know, when you get to the office there are so many talks every day, people who just come in to give a talk, that it's like, what's there on TV today? Okay, which talk do we have today? And once there was a talk on cosmology, and my office mate just told me like this, it wasn't anything secret or whatever. Oh, I love cosmology because that's what it draws me closer to God. And that was a casual remark in an office at Harvard. So when I see the creationists painting the labs of the world as places where people hate God, blah, 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 it's completely wrong. It's not like this.
Why do they have to make that false wedge that they think there's some kind of huge disconnect between science and people and faith? Now, granted, I do think you have to have methodological naturalism in science. I believe you have to look for naturalistic explanations, but a person's faith, to say that came from God, I don't got a problem with. And I don't know anybody that would ever say a scientist can't have faith. Maybe some hardcore atheists might, I don't know. But to me, I think it's absurd that for somebody to say a scientist can't have faith. What I do think is absurd is when a scientist uses that faith to try to find evidence to support what they believe rather than do the scientific method. Right?
I completely agree. But to come back to your question, why do they need that? I guess they need that just to explain how is it that absolutely no one in mainstream universities believes the world is 6,000 years old.
Nobody.
I just wrote an article in French and Spanish about this last week. So I just looked how many papers have been published in Science, Nature, Physical Review, and Astrophysical Journal. Over 2 million. Okay. There is a free database on the web. I can show you if you want, and you can just freely look at these numbers. How many of these papers sustain the thesis of a young universe? 0. So if you want to explain that away, if you are Jason Lai or Russell Humphreys, you need to tell people, oh, but these guys, they are biased, they don't want to hear about God or anything. And once I remember I posted on the Facebook groups that I belong, how is it that even people, even scientists who never heard about younger creationists, none of them think the world is young? And usually you get no answer because there's no proper answer to this. For example,
I said the same thing.
Yeah.
If they wanted to say there's evidence, scientific evidence for a young Earth, that would kind of mean to me that there should be some atheist people out there that believe in young Earth, and you don't see that, right? I mean, overwhelmingly, the scientific community accepts the Earth as billions of years old, with some exceptions and they're all young Earth creationists, right? All of them. And the ironic part, I got to tell you, is that not a single one of them will ever go on a forum like this, this channel, where they don't have the moderation, they don't have the scripted questions, where they have a free conversation, a flowing, organic conversation about what they're claiming, because they have an insulated bubble they have to stay into. Because as soon as you take them out of that, and they have to defend their actual claims with other experts, they get annihilated every time. So it's a shame. It really is, because I've been trying to get Snelling in here and Tompkins, and they've said before that they would, and then they changed their mind. And it's just amazing that you'll have experts like yourself, Dr. Hugh Ross, Dr. Fuzz Rana, Mary Schweitzer come in, and you know what? They're like, hey, I'm Christian. I'll defend my scientific views here and anywhere else, but they won't. The young creationists just won't. It says a lot. It really does.
Can I ask a question before I leave, Steve? Because I got to go.
Absolutely. While you do that, I'm going to get a mid student in here.
Okay. Hey, Doc. I'm Wayne Fillmore. Nice to meet you.
Hi.
I referred your book to a friend. I haven't read all of it, but I've been able to read a little bit of it from Google Books. And I wanted to ask, what advice would you give to somebody like myself who wants to become an astrophysicist, but I also struggle with dyscalculia? So my brain won't allow me to calculate math problems the same way everybody else's brains does. It's kind of like dyslexia, but it's with numbers. What advice would you be able to give people like me who want to get into astrophysics but are terrible with math?
I would say, so I would answer the best I can. I'm absolutely unfamiliar with this. I would say that having a problem with calculus and having a problem with math is different. For example, if by calculus you refer to not making calculation mistakes or integrated properly or whatever, I can tell you that I am a disaster at calculus. I always make mistakes. And I heavily rely on Mathematica.
Well, dyscalculia is actually a mathematical thing where you actually, in your brain, you take one number or something and you transport, you mix it up with another. It's basically like dyslexia, but for mathematics. So
I'm not sure in the big deal, because what you really need to understand to be a good physicist and even a good engineer and a good whatever is what a derivative means, what an integration means. For example, the day you understand that filling a bath tube is integrated, you got it. You need to understand the notions and the reasoning, and really well. Once you understand them really well, you're comfortable with the notions, you know how to play with them. Then the day you come up with a calculation to perform, being a simple calculation, multiplication or integration or derivation or whatever, you have tools that can help you. But it's really important to get to the point when you're familiar with this. For example, or another example, my son right now is studying first year college, and I'm always angry at this calculus machine, you know, this little machine that can plot you the functions, because it's super important. If you want to be good at all that, just you see a function and you know how it looks like, to be able to come to that point, to be familiar with these guys. Now, to be able to plot it exactly as it is without making calculation mistake, that's another business. But you need to be able to get to that point. And I'm not sure the problem you have would prevent you to get to that point. It's not obvious to me that it would forbid you to get to that point. But the problem is that usually, at least in France or Spain, people are taught the other way around. They are first taught to do the calculation, and then one day maybe understand what they are doing.
I think that's backwards to do it that way. When I learned calculus, I learned graphical first. We learned literally the concepts first. I mean, here was a function. Find the real roots. Find is going to be ascending. It's going to be descending. It's going to be relative maxima, relative minima, and that way it conceptually show people, hey, this is what a derivative is. This is the time rate of change on a tangent, you know, of a line of a curve. This is the integral. This is the area underneath. I think that is a way to learn mathematics. Now, rather than learn the analytical side first and then go back and try to learn the concepts. Would you agree?
Yeah. Yeah, I would agree. And especially in astrophysics, there are a lot, I would say, qualitative reasoning, order of magnitude reasoning. Now, from time to time, you need to just sit down and calculate. Okay. But if you look at my last papers, there are not a lot of equations inside. There is a lot of text. So I've wrote some papers with a lot of equations, but the equation never comes first. I would say what comes first is everything that allows you to get to the equation. And then solving the equation, that's another business. But I can tell you, just at calculus, not making calculation mistake, I'm a disaster.
Thank God for Wolfram Alpha, right? We use Wolfram Alpha. It's kind of like it's a great computational program.
And no one I free admit it in the community, and none of my collaborators ever complain about it. I tell Ramesh Narayan at Harvard, I'm a disaster at this, and he just smiles, and that's it. Because he knows that because I'm a disaster, I'm going to check, double check, and triple check, and at the end of the day, it can even still be wrong. But just to tell you that just having problem with calculus itself is not a problem, insofar as you understand that calculus itself is not math is more than this, more than just calculus.
Yeah, what he's actually saying, he's not saying calculus. He's saying, like I said, dyscalculia, which is it's like dyslexia.
Something an issue that I have, I think it may be the same thing, is if I see a sequence of 4 numbers, let's say 4738, I will say 7438.
Mm-hmm.
Yeah,
I do that all the time, and that is something that has actually led me down, the wrong path. But for me, it's a matter of me saying it and then me making sure that what I'm writing is appropriate for what I am trying to apply. So I've gotten in the habit of writing all of my variables down, whatever I'm working with, on the left-hand side of my paper, and then referring back to it on each step of the way. So if I'm trying to apply, whatever formula in physics, so if I'm doing like the Faraday, working with Faraday or Lenz's law or whatever, I have my base group of variables and my formula already ready. As a way to check to make sure I'm not transposing numbers.
Mm-hmm. Oh yeah, completely. I told you I also developed quite a lot of skills on Mathematica. I think based of my inability of when I was young, when I was studying, I did it great, and then I lost it, and then it's a vicious circle for me because I know I make a lot of calculation mistakes. I do it at Mathematica, and so I don't train, and so I do even more. So I try to force myself to keep hand calculating. But the bottom line is that at least in the physics I'm doing, that's, I would say, the end of the problem.
Let me ask you, that's a good point. Do you find that because of technology and things are done for you nowadays, I mean, if you want to solve a differential equation, a computer can do it in like no problem, whatever. But do you find that since maybe people are forgetting how to do it like long form by hand?
Well, for me, definitely. In my case now, I don't really know because I don't teach calculus at the university. So I don't have a first-hand experience of how the students are doing it. Every time all the kind of calculation my students need to do, they require a lot of understanding. And once you understand things, then the calculations are trivial. They are easy. So I cannot really say I don't have a first-hand experience of how students have evolved in the last 10 years with respect to this.
Well, we have like somebody in our community that claimed to be a civil engineer, and yet we asked him like, what's the derivative of x squared? Had no idea.
Steve, are you trying to introduce Dr. Antonie here to Edgar?
I mean, it's like it's like at that. If you're a civil engineer and you don't know the derivative of x squared, I don't want to go drive over any bridge you've ever worked on or building that you've ever designed. He didn't know Hooke's law. He didn't know Young's modulus. And I'm just like, okay, this is scary. But anyways, I got LeMed student in here. LeMed student is
well, Steve, I will have to defend Edgar here. Engineer is a very broad term at times.
No, he said he had a 5-year,
please,
5 years.
And he was very polite.
Yes, he's very polite.
So
but
he is technically a civil engineer.
I
he's
see.
a polite engineer.
Polite
sanitation engineer. Pseudo loves to throw in those jokes, doesn't he? But hey, LeMed, my friend, I brought
good morning.
You can speak French with.
I just woke up because I don't have classes today, so.
Oh, en français.
Eh oui, ça va, monsieur?
And we're going to sit back while you guys talk for just about 30 seconds and say stuff in French.
Okay, let's come back to French. Where are you?
Moi, je suis à Chicago pour l'instant. I'm in Chicago.
Okay. And what are you doing there?
Hopefully becoming a doctor.
In French, guys.
Ah, en français? Non, je suis à l'université de Chicago pour devenir médecin.
Ah, d'accord.
Changement de direction. J'étais dans une autre direction avant et puis commencer l'Espagne.
Et tu commences les études ou tu les finis?
Non, je commence.
Au milieu.
Je suis au début.
Donc, tu as une longue autoroute devant toi.
Tout à fait.
Bah,
et la France me manque un petit peu et l'Espagne aussi.
Yo soy español en la escuela aquí, pero no me gusta hablar español porque es una difícil.
We come back to English.
Steve, you haven't had a good paella until you've been to Spain.
I haven't had a good what?
Paella.
Ah, paella.
I don't know what it is, but it sounds good. What is it?
The national dish. It's a usually huge dish made with rice, and there's two of them. There's one that's made with meat, and one's that's made with shellfish. Depending on the, is that depending on the geographical location, Antoine?
Oh yeah, or depending.
Oh wait. Is it also known as paella?
Or depending on your mood.
We call it paella here. It's a Spanish dish.
It's a little bit like the Spanish pizza.
I love paella. There's a little Mexican restaurant down here that has seafood rice. It is the best thing I've ever tried in my entire life. It is the bomb.
Yeah. Spanish food is great because it has a lot of those small dishes instead of those giant dishes that you find in restaurants in the US. So you can snack on very tapas. Is that what they're called? Yeah. You can go to a restaurant or a bar and just order like 5 or 6 different things, and they come in like small dishes. And you can share them with people. So it's a different way of eating than going to a restaurant and ordering a giant plate.
Oh, that'd be awesome. See, I love food. I've been all over the world, and one of the best things about traveling is experiencing the dishes like Thailand and Hong Kong and Singapore. My favorite thing is foreign dishes. Now you're making me hungry, though. So I'll probably have rice now.
Steve, you were... I hope I don't shortcut you, but I think you wanted to talk about how do we know the laws of nature didn't change in the past?
Yeah, actually, in your book, you had talked about uniformitarianism, and we had a little bit of a discussion with Precept prior to going on air, going to give you a heads up on it. And I had asked, why is it we accept uniformitarianism? And you actually had put this in your book, and I think it's a great question to ask you, because there are people in this community that don't understand why we have uniformitarianism and what role it does play in science. So
mind you, that people who purport to believe in such things are scientifically illiterate themselves, completely scientifically illiterate.
Amen. So people that are illiterate. Yeah, go ahead.
To start with, a funny thing is that we have evidences, and I will tell about them after. We have evidences that the laws of nature didn't change in the past, but we don't have any evidence that the laws of nature will be the same tomorrow. That's an assumption.
Yes.
Yet these guys, each time they book a flight ticket, they entrust their life to this assumption. And in the same way, they distrust the stability of laws of nature in the past, even if we have evidences of this. So I don't see if you see the irony of the problem, that on the one hand, they entrust their life to a real assumption, because they don't have any, it's just an assumption that the laws of physics will be the same tomorrow. We don't know.
I love that answer, though.
It's funny that at the same time, to doubt the stability of the laws in the past, this stability, this is evidenced. So that was the first parenthesis, which is about the ironic, EEC way of thinking. But when I started to hang around these astrophysicists, I realized that, well, for example, when you look at the sun, the picture of the sun that you just showed us, you know not only that there is iron and sodium and all that stuff in the sun, but you know that quantum mechanics works the same in the sun than here. Otherwise, the lines wouldn't be the same. Because the reason why you have lines is because of quantum mechanics. So just looking at the spectra and spotting, here you have helium, here you have hydrogen, here you have sodium, iron, and on and on and on, tells you that, the laws of quantum mechanics, which are the electromagnetics and speed of light, because the speed of light is everywhere as a parameter in this equation, are the same in the sun than here. So it's not a big deal for the sun. Now it becomes a big deal if you're looking at a star 1 million light year away, and you find the same lines, but they look exactly the same. And I don't have to push even 1 million light years away, which on cosmological scale, 1 million light years really is next door. But even if you go to 10,000 light year or 30,000 light year, which is really, really next door, I would say it's the same apartment, it's the same galaxy, you find all over the place in in literally billions of observations, you find exactly the same spectra. The same spectra, you find the same iron lines, the same hydrogen lines, and so on and so on. And also, if you look at the molecular level. And so that tells you that the laws of physics and the speed of light is among the laws of physics. It was obviously the same, were obviously the same 30,000 years ago, because the light you see from this light 30,000 light year away was emitted 30,000 years ago. So it's kind of obvious, and you have billions of observations. It's not just one. And from time to time also I saw younger creationists attacking the way people measure the distances. And these stars, up to 30,000 light years, their distance is measured by the parallax method, which is purely trigonometric. So it's just stupid geometry. So you can have absolute certainty that at least in the last 30,000 years, and even more, because the distance ladder that people use to check the distances is not junk, that at least, I don't know, as far as people can observe, the laws of nature haven't changed. And it's the same for nuclear physics. You can observe nuclear events. So I refer to this in the book, but you have a really funny phenomena that occurs about 2 or 3 times a week. These are supernova type 1A, technically, that's how they're called. So in the book, I give the address of the web page when you have all the observations. And the light curve of these supernovas is powered by nuclear decay event of nickel 26 to cobalt and then to iron or something like this. I think it's a decay chain, nickel, cobalt, iron. And the decay rate is exactly the same. If you look at such an event 1 million light years away, you can measure the decay rate on the light curve, and it's the same than today. So we have observation. So when Kenham say, were you there? You can say, yes, I was there.
I'm looking at it, sure.
I'm looking at it right now.
I think it goes back to the young Earth creationist having to kind of put this doubt, the doubt that doesn't exist, into people's minds and say things like, well, we can't be sure radioactive decay rates are always been constant. Well, we can be sure, I know for a fact, to 1.8 billion years ago with the Oklo nuclear reactor, natural nuclear reactor, and we can look at, like you said, stars that have been around for billions of years, and and see that decay rates have been constant. And the worst part is, even if they want to have a strange hypothesis that decay rates can somehow change, whether it be a changing of the fine structure constant or the value of any of the natural Planck units, they need to come up with a mechanism how that would actually happen. And to date, not a single one of them have actually given up any kind of viable model how this would even occur. They've thrown out conjecture, but it's just like saying, well, a leprechaun can make it so, therefore it's possible. They have no science, no physics, and no mathematics to ever explain things like accelerated decay rates, because they love to throw that out there. Well, we think it appears to be old because of accelerated decay rates. Okay, well, how does that work using physics? Because you can't get around the heat problem. I mean, would you agree?
Oh, yeah. Now, or what they can do is jump on every scientific news that seems to go their direction. So, for example, they are in the labs, maybe I'm going to surprise you, but in the labs, evidences that decay rates can be slightly altered. So, for example, they love the case of uranium-187. Sorry, that seems an insult.
I've read that. I've read that one. I know which one you're referring to.
Because in the lab, so I don't remember, it have 75 electrons. So it's quite an heavy nuclei. It's used in some decay chain dating method. And people have found on experiment that if you strip all of its electrons, you can accelerate the decay rate by a factor 1 billion, I think, or something.
Yeah, it's huge. It was like 1 to the 10th. No. It was like 10 to the 9th power.
Yeah. Now the funny thing is that this experiment is a tribute to the I would say interestability of nuclear physics, because the theory was first done, and then the experiment was done to check the theory. And so it completely understood. And recently
it's not a neutral atom, though. It's an atom, like you said, that's been highly ionized. Right? Yeah, and they also quote electron capture a lot, thinking electron capture.
Yeah, exactly. You can either decay rate beta plus or beta minus if there is an electron involved, tricking a little bit with the electron cloud around. Now, the funny thing is that when you compute the temperature you will need to have somewhere uranium-187 completely stripped, completely ionized, you need a few billion degrees. And so it just vaporizes Earth.
So it's a solution creates a bigger problem. Really, life would cease to exist if they were right.
So, and indeed, also the reasoning, these stupid scientists, they didn't know about that. Stupid scientists perfectly know about that. That's why they did the experiment. Because you don't wake up one morning coming in the lab, I'm going to strip uranium 75 times and see how it decays. No, you see, no nuclei that can exist, we know. So stable, they are 180, roughly, I don't remember exactly. But unstable, we know more than 3,000 nuclei. And each of these 3,000 nuclei can have several states of ionization. So you don't wake up one day thinking, I'm going to try this one. Because there are zillions of experiments that you can do.
Yep.
So they tried this one precisely to check nuclear physics. Now in a natural condition where maybe in lightning, temperature can ionize hydrogen. Okay. And maybe helium one time. But you are not going to ionize uranium 75 times anywhere on Earth.
Right.
So that's why people who use uranium as a technique for decay chain, they know they are perfectly safe on that side. But that's also a hallmark of YEC. They don't have usually any I would say, any concept of orders of magnitude. What is an approximation?
They don't understand scale.
Where scale? When is approximation safe? Where is it not safe? For example, someone told me, the stars, they were close at the beginning, but the expansion of the universe got them far away, where the rate of the expansion of the universe at the scale of our galaxy is stupid, it's ridiculous.
Yeah, I'm glad you mentioned some of these claims, because I'm well aware of these claims. I've researched them myself, and I understood, exactly what you're talking about. They don't. These people that throw these things out there, oh, well, yeah, there's this one particular isotope they've done this with, or like I said before, electron capture, which is normally like what, if I remember correctly, 0.2% on some elements, depending on the valence shell. There's not a high amount. You're never going to get to where they want to be from billions of years to 7,000 years using electron captures. It's not going to happen. But they trotted out there like, oh, well, this changes the decay rate. Yeah, but it's so minuscule, and it's not going to get you where you want to go. But they really think it's a defeater, don't they? Things like that.
And it's also the same happens with C14, because you have a huge amount of nuclear reaction that can give you C14. So in the atmosphere, there is this bombardment by cosmic rays, which gives you a lot of C14, a lot by nuclear physics standard, so that you can date object once a tree is dead, for example. Now, when the level of C14 reaches, I would say, the noise, for example, in oil, there is C14 because there is radioactivity underground. You always have a bunch of stuff which are going to generate C14. And so they chat, oh, there is C14 in oil. Of course there is. But there is 1 million less than in the atmosphere.
Yeah, they do with diamonds too. Like I had that discussion with Dr. Safadi.
Dinosaur bones and all that.
Yeah, there's carbon-14 in dinosaur bones and diamonds. Yeah, once you look into it, then you realize that it's because they're in coal areas that have transuranic elements and uranium and thorium and a few other things that create the carbon-14. But they don't care about that. They just say, oh, look, there's carbon-14 here, ergo the Earth is 7,000 years old, even though it's completely explained. And if you find a diamond in some area that doesn't have these radioactive elements next to them, they don't have any carbon-14. If the yaks were right, all of them should have carbon-14, and they're not. So, but hey, real quick, the med student had a question to ask you. Real quick, I know we're running out of time here, so Med, my friend, you had a question?
This is going to be the battle of the strong French accents.
Okay.
Awesome.
No,
I lose. So I'm out of this one.
Who has a stronger accent? Le Med or me?
I don't like to speak with my French accent. I try to speak without the French accent.
Okay.
In US. Anyway, I had a question regarding what does Antoine thinks about the way that students in the education system in Europe compared to the US are tested. Because one thing that I noticed that's very important is that at least in France, from what I remember, we were not tested with multiple choice questions. And here it's only multiple choice question. You answer on a long piece of paper where you put a mark for A, B, C, D, or E. As opposed to France, we had to write a lot of sentences and explanation and basically present our knowledge versus what is the best answer out of those four. And I was wondering what he thought, if that could be a reason why students in the US have less critical thinking than in other countries, if I may say. Because of the methods that they're tested.
Yeah. So first, I didn't study in the US. My only contact with US students was people at the PhD level and at Harvard. So now if you tell me that it's mainly by multiple choice, I don't think that it's the best way to develop critical thinking and all that. Now, I don't know if there is this multiple choice is all the way through school and middle school and high school and all that, because I remember in 2012 we spent with my family 8 months in Boston. We were living in Newton, a suburb of Boston, and my kids would go to public school there. So my daughters were in elementary school, and my boy was in middle school. And I remember that they had much less homework than in Spain or France, and that a lot of the lessons were specifically done to develop critical thinking, discuss something that happened. For example, I remember my daughter coming one day from school. Today, the teacher just threw on the table a plate. It did a certain noise, and then we discussed why it did that noise. I found it funny.
I think you have the stronger accent, by the way, Antoine.
Oh,
you do. But
okay.
I can kind of answer that question a little bit from my perspective as being an American. Lamed, yes, absolutely, multiple choice sucks. And when I went through nuke school, there's no such thing as multiple choice. And we have a running joke in nuclear power school, which was the questions, and this is true, it's not even a joke, but it's the questions were literally said things like briefly explained in detail. And you really had to put as much as you possibly can, like a paragraph or two. That's considered brief, but detailed. So it's briefly explained in detail. Everything was an essays type style. Everything was, okay, show all your work. There's no multiple choice in that particular school, and it's hard. But I think you actually learn the material far better than multiple choice. And also with multiple choice, there's some vagueness there. I don't do well on multiple choice because I overanalyze shit. And I'm thinking to myself, a lot of times they might be trying to trick me, or the answers may not be perfect, right? Like it's the best guess what you want to answer in multiple choice. And I think that's crap. So does that help?
Now it's true that on the teacher side, correcting multiple choice is much easier.
Sure. Oh yeah. But the best part is with the paragraph, when we would get the test back, we actually go over each test, and if you can point out that you had actually made a concept that they didn't give you a point for, you can get points. There was 3 degrees of what they would write. They would say CE, which meant conceptual error, which is basically you just kind of might have boo boo. You had GCE, meant gross conceptual error. That means you're way off the mark. I think I only had like 1 or 2 of those. And then you had WTF, and we all know what that means. If you got a WTF, that means that you were so removed from reality on your answer that you might as well like just dropped out and become a line cook or something.
So you just go put the pickles on the bun then?
Yeah, that would have been basically like true empiricism, like every test. WTF, that would have been. So I hope that kind of answers the question from an American point of view, Lamed.
Oh yeah.
Yes. Yeah. But I know we're getting kind of late here, so I kind of do want to wrap this up. In kind of a summary, Dr. Bret, you definitely agree with us then, in no uncertain terms, that everything that you had read that I had sent you, which was verbatim from Sieg Brown, was 100% bullshit.
Yeah.
Okay. I tell you right now, he's gonna.
I had to say this, but yes.
I don't. Yeah, no problem. Because he's be like, well, he wasn't quite sure if I was right or wrong. He never said I was actually right or wrong. Yeah, C. Brown, you're wrong. So deal with it. But anyways, I want to wrap this up. I want to thank you very much for coming in and joining us.
You're welcome.
I loved it. I've talked to you for quite some time on the Facebook creationist pages, but this is the first time we've actually had a chance to interact. I'm sure it's going to happen much more when you have time. But I do want to thank all the people that watched today. Not a huge turnout. It is 9 o'clock in the morning, so it's only about 40 or 50 that we had watching. But a lot of people will as the day goes on. I do want to thank my new sponsor that I got, Brian Sapient, who was kind enough to donate some funds. And I said I'd be more than happy to put his sponsorship links into my videos, which was Atheist United and Celeb Atheist. So to go check out those links, go check out the link to Dr. Antoine Bret's book. The world is not 6,000 years old. So what? I haven't read it yet, but I think I'm going to. But I've got this other couple books to finish here. In fact, I think Lamed, you had sent me Cosmic Landscape. I got about a quarter way through that one. Then another friend of mine sent me Strange Planets. So I got some serious reading to do. So when I get done with those, then I'll work on yours. How does that sound? Dr. Bret, you there?
Yeah.
As soon as I get done with these books, I'm gonna get to yours and read yours as well. Okay. But anyways, guys, thanks for watching. Thanks for listening. This was a fantastic hangout. I was really excited that I had a plasma physicist come on, and we can kind of discuss some of the claims that the Clown Car Posse has put out. People in the live feed are saying, very nice guest, keep you around, and they really enjoyed this. So the live feed has been jumping ever since we started. So I really want to appreciate you coming in here, Lamed, coming in, Pseudo, and everybody else who joined us. And with that, I'm going to say goodnight.